Dear students, in today's session 3, we shall discuss some of the aspects regarding wave function. Myself, Dr. Ganesh Acharya, Assistant Professor, Department of Chemistry, IDSG Government College, Chikmagaluru. Wave function is a very important term that is used in quantum mechanics. It is very similar to as that of the amplitude that is used in the classical mechanics. In quantum mechanics, the object is completely described by a complex wave function given by the symbol psi, and it depends upon the particle's position and time. The wave function is interpreted as probability amplitude of particle's presence. So in classical mechanics, the system is described by a trajectory. In quantum mechanics, the system is described by a state or a wave function. The probability density means probability of finding a particle at a time t inside an elementary volume dx dy dz is given by psi square dx dy dz. Moving further, in quantum mechanics, it is very important to consider the wave particle duality. And in the classical mechanics, the particle is moving along a definite path, and in the quantum mechanics the particle is distributed through the space. So therefore, instead of using a trajectory, we have to use a wave function in quantum mechanics, and the wave that in quantum mechanics replaces the classical concept of particle trajectory and is called as wave function. A wave function in quantum mechanics describes the quantum state of an isolated system of one or more particles. There is one wave function containing all information about the entire system. Okay, so the state of a quantum mechanical system completely specified by a wave function, and psi square gives the probability density of finding a particle in a given space. Now, physically acceptable wave functions must have the following important features. First one, it must be finite and single valued. This means that for any given value of x and t, psi of x comma t must have a unique value. So therefore it must be finite and single valued. This is a way to guaranteeing that there is only a single value for the probability of the system being in a given state. So the first point is wave function must be finite and single valued. Second, the wave function must be square integrable. In other words, the integral of psi square over all space must be finite. So this is the second point about the wave function. And third point, it must be continuous. Okay, so the wave function must be continuous. A rapid change would mean that the derivative of wave function was large. So in the limit of step function, this would imply an infinite derivative. Since the momentum of the system is found using the momentum operator, which is a first order derivative, this would imply an infinite momentum, which is not possible in a physically realistic state. So therefore, the three important points you must have to consider about the wave function is it must be finite single valued, and it must be square integrable, and then it must be continuous, and it describes the state of a system completely. Now, the physical meaning of wave function is as follows. So first thing is the wave function psi n and the corresponding energy En, which are often called as eigenfunctions and eigenvalues respectively. That means here psi n is called as eigenfunction, En is called as eigenvalue, which describes the quantum state of a particle. Second point is the wave function psi has no direct physical meaning, as I told you earlier. It is a complex quantity representing the variation of matter wave. It connects the particle nature and its associated wave nature. Okay, so therefore psi itself doesn't have any physical meaning. And psi star or psi square is called as probability density function, and it gives the probability of finding a particle in the region of space between x comma x plus dx, y comma y plus dy, and z comma z plus dz. So psi doesn't have any physical meaning, but psi square has the meaning called as probability density. If the particle is present, then double integration of psi star dx dy dz is equal to 1, and it can be considered as probability amplitude since it is used to find the location of the particle. So these are few important points about the wave function. So the wave function psi n and corresponding energies En are called as eigenfunctions and eigenvalues. Wave function psi doesn't have any physical meaning, but psi square has a meaning called as probability density. And wave function connects the particle nature with its associated wave nature. And next point is, if the particle is present in a given space, then double integration of psi star ds dy dz is equal to 1. Then it can be considered as probability amplitude since it is used to find the location of the particle. So these are few aspects you should remember about the wave function. You can go through these references. In our next class, we shall discuss few more aspects about the wave function and its importance. Thank you for watching this video.